Hello everyone. My name is Ujjwal Puri. I am a third year student at Tribhuvan University, and I'm currently majoring in computer science and information technology. I've been working as a software engineer for a year now. My primary stack is Python and Django. For quite a long time, I wanted to switch careers into machine learning engineering, seeing how lucrative it is. One of my seniors said that machine learning is 90% software engineering and 10% machine learning concepts. Following that, I ventured into the software engineering industry, but now I feel like it's the time for me to make a shift, and for that, I need strong machine learning knowledge. And I think this fellowship is the right place for me to achieve that. Thinking of that, I've also heard quite a few positive remarks from my seniors that have previously taken this fellowship, and I'm really excited to be part of this. I hope you give me a chance. Now we move to our code explanation. So the first thing that you will see here is the packages that have to be installed to make our machine learning model. The first package is NumPy, and NumPy is like a super calculator for numbers. It helps us handle big chunks of numerical data really quickly and efficiently. Think of it as the backbone for most data processing in Python, and it is super fast and it is also very reliable. Then there is pandas. Panda is like a go-to librarian for data. Imagine you've got messy data from an Excel sheet or a CSV file. Pandas cleans it up, organizes it into tables, and lets you analyze it easily. It's like a spreadsheet buddy. Then we have TensorFlow. TensorFlow is the wizard of machine learning. It's what helps us create and train smart models to recognize patterns, make predictions, and even power cool stuff like chatbots or image recognition. It's the magic behind AI, and it's like the most go-to package that is used in artificial intelligence. First of all, we have to install these, and then we make our imports. The first thing that you will see is um, pandas, numpy. I've explained these, and then this is scikit-learn. This is another package that you require for machine learning. And then we have I think there we had okay, so we will be looking into these in depth with the code. Let's go into code. I will give in-depth explanations on these packages as we move into the project. The first thing that we have to do in order to work on this machine learning project is to load the data set. In this data set, so this data set at first needs to be downloaded in order to be used with Colab. I'm using Colab because it provides free resources in terms of GPU, and as the data set is used, we would need extra resources. It would not be possible to do simply with CPU. It is possible, but it takes a lot of time. So we are using Google Colab. As you can see, I've written some code in order to install this in my Google Drive, and written some code in order to point out exactly where the data set is in the Google Drive. When you first download data from Kaggle, it is downloaded in terms of zip. So we have to first unzip it and then actually load the data set. So the first step that we're going to do is we're going to visualize the data set. So here you would see that we are using matplotlib in order to show that the sentiment distribution, or the number of negative reviews and the number of positive reviews are same in the data set. So it's not heavily skewed towards any one direction, which is like a massive plus because it helps to give correct estimations of the reviews. As there are equal number of positive and equal number of negative reviews, every time it encounters a newer review, it can easily differentiate whether it is a positive or it is a negative review. Now, as you can see in this plot, the sentiment distribution is pretty equal. And I've also written a code. Like, this is pretty simple. It basically, as you can see here, what I've done is I've replaced positive with 1 and negative with 0. This is simply because it gets easier to deal with ones and zeros than actual words, positive or negative. So this is basically a simple line of code that does that. And as you can see, I've listed a few reviews. So basically in the data set, you have a review like this, and it basically has the sentiment value, which is 1. 1 means it is positive, and 0 means it is negative. So another way to visualize data, another thing that I've done to visualize data is to find out number of duplicates in the data sets. And as you can see, the number of duplicates are 418. uh, now now the thing that we're going to do is we're going to divide the data. For this, we're using a super handy function called train test split, which comes from the scikit-learn library. This function is like a chef dividing ingredients for two recipes, that is training and testing. The training set teaches our model, while the testing set checks how well it has learned. And here you can see that we have three parameters. One is data. This is the full data set we want to split. It could be anything: CSV data, text, images, you name it. And then we have test size, which is 0. 0.2. This means 20% of the data goes into the test set, while the remaining 80% stays in the training set. You can tweak this ratio depending on your project's need. And then you have random state 42. Basically, it's the famous 42. This ensures the split is reproducible no matter how many times you run the code. You'll always get the same training and test data. It's like setting a seed for shuffling the data set. So, all right, now let's talk about preparing text data for our model. This part is super important because raw text can't be directly fed into a neural network. We'll convert it into something the model can understand, which is numbers. Let's break down what's happening here. The first line of code, tokenizer equals to tokenizer function bracket num words 5000. Here we are creating a tokenizer object from Keras. This tool will turn our words into numbers. The num words 5000 parameter tells the tokenizer to focus on the 5000 most frequent words in our dataset, ignoring the rest. If you're considering why, if you're asking why we do that, because it helps keep the vocabulary manageable and avoids noise. Then we have tokenizer.fit on text. We are basically training or fitting the tokenizer on our training data, specifically the review column. This steps builds a dictionary where each unique word gets a unique numeric ID based on its frequency. Common words like the or and might get lower IDs, while rare words get higher ones. So that is how it works. Then we have pad sequences. The then Okay, so these line of codes like tokenizers, text to sequences. Uh, Wait, yeah, these tokenizer.text to sequences. This code is responsible for converting each review into a sequence of word IDs. For example, the sentence "I love movies" might turn into 12, 43, 85 if those numbers represent the words "I love" and "movies" in the tokenizer's dictionary. Then the pad sequences function. Not all reviews are in the same length, so we need to ensure they're consistent. Pad sequences makes this happen by either truncating long sequences or padding shorter ones with zeros. The max length 200 parameter means every sequence will be 200 tokens long, so it basically introduces uniformity. Uh, After these steps, xtrain and xtest are ready for the model. They are now matrices of size 200, each num samples 200, where each row is a sequence of numbers representing a review. This is what our model will be trained on. Now we're actually training the model. Uh, Now we're actually training the model. So now that our data is ready, it's time to build our model. We're using a sequential model from Keras, which allows us to stack layers one by one. So the first thing that you will see is this sequential function, right? So this sequential function is basically helping us define our neural network. The first line of code is this embedding layer. So this first layer in our embedding layer, it has three parameters. The first one is input dimension. This is the size of our vocabulary. We've told the tokenizer to focus on the top 5000 most frequent words, so the embedding layer will look up these words in its vocabulary. Then we have output dimension. This is the size of vector we'll use to represent each word. Each word in the vocabulary will be transformed into a dense vector of size 128. These vectors capture semantic relationships between words. And then we have input length of 200. Each input sequence will be of length 200, which we said earlier when padding. So each review will be represented as a 200 length sequence of word embeddings ready to be passed to the next layer. Another layer is this long short term memory layer. So Uh, this is a special type of recurrent neural network that's great for handling sequential data like text. The first thing that you will see is the number 128, and this is the number of LSTM units. You can think of these units as neurons that process the sequence. More units help the model capture more complex patterns. Then you will have this dropout parameter, which is basically set to zero point 0.2. This is a regularization technique to prevent overfitting. It randomly drops 20% of the LSTM units during training to ensure that the model doesn't memorize the data too much. And then we have recurrent dropout. This also applies dropout to connections between the LSTM units, ensuring that the model doesn't rely too heavily on any specific connection, improving generalizations. And then we have the final layer, which is a dense layer, and this is just a regular fully connected neural network layer. The first thing that you will see is the number 1 inside it. We are setting the output size to 1 because we're solving a binary classification problem, which is either positive or negative, basically 1 or 0. We also have an activation function, that is the sigmoid activation function, that squashes the output to a value between 0 and 1, making it perfect for binary classification. If the output is closer to 1, it's a positive review. If it's closer to 0, this means negative, which basically means negative, right? Then we have the summary of the model, and now we have, if you look into the summary of the model, it basically gives you an idea of, I don't think it's working quite well, but we'll get back to it later. Then we have the compilation model.compile function. And the first thing that you will see inside this compile function is that you will see the optimizer parameter, which basically states Adam. Adam is a popular optimization algorithm. It helps the model learn by adjusting its weight during training to minimize the error. It's known for being fast and effective in many types of problems. Another parameter is loss parameter, which states binary cross entropy. And this is the loss function used for binary classification problems. It calculates how far the model's predictions are from the actual results, either 0 or 1. And then we have another parameter metrics, which basically has an array that contains accuracy. This specifies the metric used to evaluate the model's performance. Is accuracy, and this will track how many of its predictions are correct compared to the actual labels. Now we're training it. This is basically done through the fit function. The first thing that you will see here is xtrain and ytrain. This is the data we feed into the model. Xtrain has all our features, basically the information the model uses to make predictions, and ytrain is the actual answer we want the model to predict, like whether an image shows a cat or a dog, in this case positive or negative. And then we have epochs, basically we've set it to 5. This basically is going to make sure that a model goes through the data 5 times. Every time it sees the data, it gets better at predicting that data. And then we have batch size 64, which is set to 64. Basically it says, hey model, don't try to learn from all the data at once, take it in chunks of 64 samples at a time. This helps the model learn effectively without overloading the system. And the final parameter inside this fit function is the validation split, which is set at 0.2, which tells the model to save 20% of the data for checking its progress. It's like giving the model a quiz during its training to see how well it's doing. And now the first thing is, and after training our model, what we're doing is evaluating. We are checking the total loss and then the accuracy, which seems to be pretty fine for this case. Now we are actually making a prediction system. The first prediction system, this function, is generally we write a review and we pass the review inside this function, and it gives us the idea of whether the prediction is positive or negative. The first line inside this function is sequence equals to tokenizer dot text to sequences review, as you can see here. And this basically means that now that we have our sequence of numbers, we need to pad the sequence to make sure it has the right length of our model. Like, this is super important because the model expects input with a fixed size. We are padding it to 200 words here, and then we have this padded sequence function, sequence dot comma max length. And now the review is all set. We pass it through our model with now the magic happens. As you can see, we are basically passing the padded sequence to our prediction model, and we have this sentiment equals to positive. this line, this basically states that if the prediction value is greater than zero point 0.5, the review is positive, and if the prediction value is lesser than zero point 0.5, then it is considered as negative. uh, you can see the working of this function here. Basically, I've given a review. This movie was fantastic. I loved it, which is certainly a positive review. And if you pass it, it gives the answer that it is positive. And another example is a negative example where basically we say this movie was okay but not that good. We pass it inside this function that makes use of our model, and then it provides a negative value. So this is how our machine learning model works on the IMDB dataset, which basically has reviews, and we can easily classify whether that review is positive or negative. And every time a new user provides a review on that movie, we can pass that review inside our machine learning model, and we can find whether the whether the review was positive or negative. So yeah, thank you for sticking with me. I hope you give me a chance to um, improve myself through this fellowship. If there are any questions regarding my code, or if there are any questions regarding how I did this, I would love for you to contact me using my email or anything. Yeah, thank you very much. I hope to see you in the fellowship. Thank you very much.